Hello, I am Austin Henry. I am presenting problem number 11 from chapter 2.7. This is dealing with rates of change, particles moving, velocity, acceleration, etc. So to begin with, we start off with a position function that is s of t equals t to the fourth minus 4t to the third minus 20t squared plus 20t, where t is greater than 0, greater than or equal to 0. All right, the first part is asking us, at what time does a particle have a velocity of 20 meters per second? All right, so for the velocity, we take velocity equals the derivative of the position function, which means we do 4t to the third minus 12t squared minus 40t plus 20. And now because we want to find where the particle has a velocity of 20 meters a second, we set it equal to 20. Right off the bat, we can tell that if we plug in 0, t equals 0 into everything, 4 is minus 40 times 0 plus 20 gives us 20. So we know that t equals 0 is one solution. But in order for us to find the other values, because there's more than just t equals 0, what we want to do is, like what we have here, 4t to the third minus 12t squared minus 40t plus 20 equals 20. And now we solve, so we'll subtract 20 over, which will leave us 4t to the third minus 12t squared minus 40t. And from here we know we can factor out a 4t, which would leave us with t squared. All right, 4t, which leaves us with t squared minus 3t minus 10 equals 0. All right, and now from here, we factor, and we find that t minus 5t plus 2 equals 0. So t equals 5, t equals negative 2. But because t is greater than or equal to 0, we can get rid of t minus 2 and keep t minus 5. So we have two solutions. We have t equals 0, and we have t equals 5. Now, that was part A. Part B, asking us at what time is the acceleration 0? Is the particle moving forward or backwards when this happens? All right, so velocity, or acceleration, is the derivative of the velocity function, or the second derivative of the position function. So we get 12t squared minus 24t minus 40. Now we want to find out where that equals 0, so we set it to equal 0 again. All right. Now we can go and we can factor out a number to give us a smaller value, but what's going to end up happening is we're going to have to end up using the quadratic equation, quadratic formula. Oh, you can see that. All right, so what I've done is I factored out 8, which would leave me with 3 over 2t squared minus 3t minus 5 equals 0. So now when we come and use the quadratic formula, we have it's negative b plus minus square root of b squared minus 4ac divided by 2a. All right, so we can plug in our values. So because it's a negative 3 here, we can plug in 3 plus minus 3 squared, negative 3 squared, minus 4 times 3 over 2 times c is negative 5 divided by 2 times 3 over 2. Now, as we move forward, we can get rid of 2 times 3 over 2 by canceling out the 2's. So we know our denominator is going to be 3. So we have 3 plus minus 9 squared square root 9 minus 4 times 3 over 2 times negative 5 is, well, negative 4 times negative 5 will give us positive. So it'll be plus 30. Plus 30. Which gives us 3 plus minus square root of 39 over 3. Alright. So we have two answers. We have 3 plus square root of 39 over 3 and 3 minus square root of 39 over 3. Now because we want to keep all the t values greater than or equal to 0, this is less than 0, this is greater than 0. Alright. So here are our solutions. This is our solution to where acceleration equals 0. Now the second part of that question is the particle moving forwards or backwards when this happens? So what we want to know is in what direction is the particle moving? And what we use is, I'm going to flip the page. What we use is, well, because we know two places where velocity equals 20 at t equals 0 and t equals 5, v of t equals 20 meters a second. That kind of gives us an idea of where velocity sits in between. The velocity kind of sits, a of t equals 0 sits in between there at 3 plus square root of 39 over 3. Alright, so what does velocity equal when acceleration equals 0? And what we find is we can go above or below this number, because this number would be too tricky to try and plug into an equation. So we'll plug in 3. So we'll have the velocity equation, which is v of 3 equals 4 times 3 cubed minus 12 times 3 squared minus 40 times 3 plus 20 equals do 27 times 4, 8 minus 12 times 9, 18, 8. Minus 40 times 3, 0, 12, plus 20, which gives us 20 minus 120, negative 140 plus 20 equals negative 120. Alright, so velocity equals negative 120 meters per second. Alright, now because velocity is negative, the particle is moving backwards. So acceleration equals 0, velocity is negative 120, so the direction is backwards. We know this because anything below 0 is moving backwards. Alright, now we have a true or false question for number 2. If the acceleration of a particle is constant, then the particle must be speeding up. Now, what do we know about speed? Speed equals the absolute value of velocity. So no matter in what direction, plus or minus, speed is directionless. So if the acceleration of a particle is constant, that means, well, we know the acceleration equals the derivative of the velocity function. So because acceleration is constant doesn't mean the particle is not moving. It's accelerating at a constant rate, which means every second it's getting faster and faster. So when we answer this question, if the acceleration of a particle is constant, we know that the acceleration is moving at a constant rate, but it's getting faster and faster, which tells us that the particle is speeding up, which leads me to say that this question is true. Thank you. Hope this helps.